And welcome to the Smash News Network, least busted name in news. Welcome to fall. Congratulations on surviving another season. It's a very scary and spooky space out there. Oh my God, I'm completely spooked. I'm completely spooked right now. I'm so spooked. We're going to talk about cosmology today. We're going to talk about new sunspots having risen and lots more, weather forecasts, and so on. So thanks for stargazing with us. That's the last 24 hours. Let's take a look at yesterday plus today. New sunspot there rising in the northeast. So there's your intensity gram. Sunspot number will have increased once again by the end of the day today. We've got multiple beta gamma class sunspot groups. There's your colorized magnetogram for yesterday and today. So a little uptick here in solar activity. Let's take a look at volcanoes briefly. What's erupting, you ask? Kluchevskoy, although volcanic ash not identifiable in satellite imagery. Also, Abiko has produced a 10,000-foot plume of volcanic ash. Sakurajima, 10,000-foot plume of volcanic ash there at Sakurajima. I think that is an uptick. Suminosejima also exploded. Produced an unknown size volcanic ash cloud. Please do not pole vault the caldera. If you visit the volcano, leave your vault pole at home. Mount Ibu also exploding, flight level 070 over Halmahera. And the new island in the Tonga Home Reef continues to probably grow as lava oozes out. And it's currently about 211 meters now, so it has grown since the last time we covered it in terms of its size. Some new real estate forming. Let us know in the comments if your real estate prices are dropping in your area as a result of that. Yes, I know, interest rates are rising. Oh my God, dear God. Popocatépetl also exploding, flight level 190. Sangay exploding, flight level 210. Ravenador exploding, flight level 160. And intermittent emissions from Sabancaya. Who knows what the size of the ash plume is there over Peru? Let's take a look at earthquakes, which have been somewhat calm here over the past 24 hours, it looks like. No large quakes. A little swarm there on western South America. Looks like nothing even of a 5 magnitude. Well, there was at least one 5. There's a 5.2 at Tonga that happened at 16:18 yesterday afternoon. That's 16:18 Universal Time. So again, pretty calm here as far as earthquake activity. Just scrolling up the list. Scrolling. It's not really very much worth commenting on. If we've missed anything, let us know in the comments. And thanks to everybody who has commented over the past 5+ years. A 10.7 centimeter radio flux about to come up. It's only at 137 solar flux units at the moment. Seeing it level off there in between 140 and 130. If you're wondering what a solar flux unit is, that's what we use to measure the 10.7 centimeter radio flux. A solar flux unit is equivalent to 10,000 joules of radio flux density. So there's the Space Weather Enthusiast dashboard. NOAA did forecast some geomagnetic unrest and storm conditions today. We haven't seen it yet. The current coronal hole high-speed stream has been kind of weak. And for everybody who is forecasting a Carrington event, where is it? Are you going to admit that you were wrong? Are you going to admit that the paper about it was based on an over 1,000-year-old religious text and was not anything resembling science? I'm sure you won't. You'll probably attempt to gaslight people. So good luck with all of that. Good luck with all of that. So we still may see geomagnetic storm conditions, but at the moment, the coronal hole wind stream is looking weak. Here's the last 4 hours of Earth geospace. Let's shrink that down one level. Last 4 hours of Earth geospace there, the magnetohydrodynamic pressure out to about 12 Earth diameters. Looking pretty calm here. Despite only a small uptick in solar wind density, I don't think we've even seen an uptick in the velocity yet, maybe showing up a little later than NOAA forecasted. We'll see what happens. Here's the last 4 hours of Earth's magnetic moment from the ground. And there are certainly some aurora sparked from the little recent density uptick. We'll talk about that here in a couple of frames. And make sure you stay tuned for the cosmology segment today, folks, because we'll be talking about a little bit about the galactic structure. So here's the Planetary K Index. It is now at 3. KP3 is the current geomagnetically calm condition that we're seeing here on planet Earth. So here we see this tiny little uptick in the solar wind density. It's barely even worth mentioning. It made it up to about 16, nearly 17 protons per cubic centimeter. So if that's all we're going to see from that coronal hole high-speed stream density wave, that's going to be a pretty weak coronal hole wind stream indeed. Current conditions are just under 7 protons per cubic centimeter, solar wind speed only 407 kilometers per second. I think we can expect a little bit bigger increase than that. So in the next few hours, I would say we're going to see a larger density increase, followed by a decrease in the density and an increase in the speed. This is not yet the real incoming coronal hole high-speed stream. So here's the GOES magnetometers over the past 3 days. That's the GOES 16 and GOES 17. Looks like the GOES 17 had to do some maneuvering. That's what those arc-jet moments are. That's the use of their thrusters, which can affect their magnetometer, so they show it as arc-jet moments. And if you think NASA is hiding data, please leave us a comment, and don't be angry if we berate you in the comments section. Next, the top view ecliptic plane field plot, part of the National Sunspot Observatory data, which comes from 51 ground-based magnetometers, as well as magnetometers on stereo A, which is right there at Lagrange 5, and stereo B, located right there at Lagrange 4. And there is a North Pole current sheet rushing this way, and it may be delayed depending on what kind of activity we see. So let's take a look at the line of sight field plot showing the sun's B field in blue, the north solar polar field in green, south solar polar field in red, before we move to coronal holes. Again, a new sunspot is rising in the northeast. We'll cover that here in a moment. Here's their coronal hole line of sight plot, and the current earthly facing coronal holes, and the one that's expected to provide somewhat of an increase in the solar wind density coming soon. They're all south pole oriented, some north pole oriented coronal holes here rotating in also. You can see those in green there on the eastern limb. Here's the 211 angstroms wavelength from SDO for the past 24 hours. And I would note something, folks, that these are just a lack of certain chemical species, okay? So that's those areas there, what that's depicting is a lack of this specific species of iron, 211 angstroms. It's one type of ionized iron, and there's just a very low amount of it at those spots where you see those coronal holes. In contrast, these white spots, those are where there is a lot of that species of iron. Let's take a look at those coronal holes in a little bit more close detail. So what's interesting about coronal holes, of course, folks, is that it tells us something about what's going on chemically in the solar corona. Because in other wavelengths, you don't see those coronal holes. It's just for some reason that species of iron doesn't like to be in those areas. Not to suggest the iron is conscious. Let's move to sunspots. And there is the flare probability. It's going up a little bit here. This group up here is beta gamma class. I checked before I did this stream. So yeah, that's what's going on. It's going to be sunspot 3110. For some reason, this group back here didn't get named. I don't know. I don't care about the naming conventions. I don't get hung up on the names. Expect the radio flux to go up. as a result of that new sunspot rising. So here's your 24-hour SDO magnetogram. We'll also show the SDO continuum imagery after we show the 171 angstroms wavelength, the house favorite. Shout out to Smash staff. Smash staff doing a fine job being our IT department and our social media manager. Here's the SDO continuum imagery. And most of those sunspots have been rather stable here. A little bit of a disparity in the rotational speed there. You can see some of those fields are rotating a little faster than other fields. Some interesting turbulent activity going on there in the achromosphere. Photosphere. I'll say both. No spikes in the proton flux. We've been seeing that subsiding here. And flare activity has been kind of low here, but you can expect to see the background X-ray output to go up a bit here as, again, a new sunspot's rising. We've got quite a few sunspot groups in the southern hemisphere. Likelihood of flares going up a little bit there. And here's a good wavelength to view flares, 94 angstroms. And if you thought the sun was going to kill you today or end civilization, sorry, still not happening. Sun's not going to kill you. It's not going to kill you today or ever, in all likelihood. And if you've got some kind of argument about that or some sort of a valid physics explanation of why it would, by all means, let us know in the comments. And don't leave links to idiotic YouTube channels who cite propaganda, who create propaganda. Here's our star chart. We've got a lovely crescent moon having just risen here over Lehigh Valley, Pennsylvania. We've also got Mars up near the apex of the ecliptic. And Jupiter in a setting mode down there in the east. I mean the west. Yeah, the west. That's where things set. And let's do a solar system forecast. We've got a crescent waning moon as new moon approaches. Oh my God, folks. I got to tell you, new moon is approaching, which means reverse werewolves will be at the peak of their activity, which means they'll be sleeping well, being happy, productive members of society, not cannibalizing humans or worshiping Satan. They'll be just, they'll be reverse werewolfing, sleeping well at night and so forth. The features of a new moon. Oh, knows it's very scary. Oh, if you're going to cast spells, make sure you cast them on the new moon. Oh, because you wouldn't want the moon interfering with your spell casting, right? Here's your 1 week forecast for the solar system. Here's where things will be in a week. For all you wizards out there who think you should only cast spells at full moon, there'll be a crescent waxing on September 30th. Now let's talk cosmology right after we welcome you to fall. So we're only 8.5 hours into fall here at the moment. Wait a minute. 9 hours and 8 minutes into fall at the moment. It's our equinox count up. Yes, we did a live stream about it last night. If you didn't catch that, I'm not surprised. And let's talk about cosmology. So we used to do cosmology segments on the regs, and we're just too busy at the moment to do it. Let's talk about cosmology briefly. There is one X-ray source that I follow all the time. It's one of the brightest X-ray and gamma ray sources, and the brightest intrinsic object, the only known cosmic ray point source known as Cygnus X1. It's the tail of the swan, Deneb, in the constellation Cygnus. And we do have an entire forum thread about this. And I just wanted to tell you about some other objects that are followed here. So at the Swift-Bat X-ray Observatory, it's the Neil Gehrels Swift-Bat X-ray Observatory. There are over 1,000 objects that are followed here. Your favorite object might be shown. So let's take a look at some other X-ray sources here, shall we? So we're going to look at Cygnus X1. It's another very strong X-ray source, and it's famous because it's the first object believed to be a black hole. Carl Sagan and Stephen Hawking bet on this, and there you can see the X-ray outputs from Cygnus X1. Now this is hard X-rays, and the range here is 15 to 50 kiloelectron volts for those photons, that ionizing radiation there coming from inside our galaxy, from the constellation Cygnus, that object there. So this is the historic data back to 2004, and then down here you have the 30-day data. And as you can see, it's got quite a range there, significant range there historically speaking, of X-ray output. And it's a fairly strong X-ray source. Next, let's take a look at, how about the Gaminga Pulsar. So there's the Gaminga Pulsar, another X-ray source from within our galaxy. And it's more of a steady X-ray source, and it's not quite as strong as Cygnus X1. But there you go, there's the 30-day graph of Gaminga, and the historic graph back to 2004 of Gaminga. How about one more? How about, let's see. How about Sagittarius A star? So if you're not familiar with Sagittarius A star, Sagittarius A star is the galactic core of the Milky Way galaxy. And most of the stars in the galaxy are orbiting it. Anyway, there is the X-ray output of Sagittarius A star, the galactic core, and you can see there that it's a fairly consistent X-ray source, but also a fairly weak X-ray source. Why? Well, it's partially because the jets aren't oriented anywhere near our solar system. They're oriented sort of not even perpendicular to the galactic plane. They're at kind of a weird angle, like a weird 40-degree angle with respect to the galactic plane. But, okay, so it's not finding that. Let's use a basic query. To find it in Simbad, and there you go, there it is. There is Sagittarius A star, and it's going to be dark in most wavelengths because there is a lot of dust in between us and it. So let's head to the CDS portal here real quick to look at this in some additional wavelengths. So there it is on the DSS. That's visible light, and you can see there's nothing but darkness and visible light in that area. It's because there's a lot of stuff in between us and Sagittarius A star. Part of the reason why it looks dark in most wavelengths. Now, let's take a look at this in infrared. So here's the imagery from the 2 mass. And now you can see it's quite bright in there at the galactic core. And when we zoom out, you can see the shape of the galactic disk. Of course, there's a lot of heat, which is what infrared light is, coming from the core of the Milky Way galaxy. Now, we're tens of thousands of light years away from that, which is why that doesn't interact with the sun in any meaningful way. The way energy is imparted throughout the galaxy is through the spiral arms. So, again, there's a lot of stuff in between us and Sagittarius A star. And while stars do likely interact with each other, the sun is not interacting with Sagittarius A star. So that's the point I'm trying to make here. Let's bring up one more object here, something a little more interesting to look at since we decided to hit up the portal here. So let me just go back. We're going to head back to our Neil Gehrels Swift-Bat X-ray Observatory since you can link directly to objects. And let's take a look at Gaminga. In fact, let's take a look at Vella. We'll look at the Vella Pulsar real quick. So you hit Control F. There's the Vella Pulsar. An interesting object within the Milky Way galaxy. Once again, it's a quite strong X-ray source here. You can see the cyclicity of it. It's not very cyclical. It's sort of chaotic and random in terms of its X-ray outputs. If you click Simbad, You'll be able to take a look at the Vella Pulsar there in various wavelengths. I always like to bring up the CDS portal. And the Vella Pulsar is very well studied because it is a very interesting object. So let's take a look at this one in some various different wavelengths here. And let's include all of the wavelengths. So it is indeed a bright gamma ray source. We're not going to worry about that too much. That's not very exciting imagery. Let's see if it shows up in Chandra. There's the imagery from Chandra. And yeah, Vella Pulsar is certainly an interesting object. And you can see the jet-like features there, sort of in these orientations. Let me just draw all over that great imagery there. You can see a jet kind of oriented this way, and another jet sort of oriented that way. Just fantastic imagery there from the Chandra X-ray telescope. And let's switch this to infrared. Not sure if it's going to show up in radio or not, but those are indeed radio jets also, which seem to be a feature of all stars, by the way. Let's see here. These things may not be good surveys for this area. Let's see what we get in infrared. Let's see if we can find the 2 mass somewhere on here. How about the Spitzer? Spitzer showing a heap and helping a nothing. Now usually when we do cosmology segments we have this all prepared. But in this one I just want, there's the 2 mass. So interestingly, the heat output of Vella Pulsar is very different from the X-ray output. That's the point I'm making. And let's move on. That's our cosmology segment for the day. Let's move to coronagraphs. Since this is a space weather video, let's get back to the regularly scheduled space weather. Now we may have some CMEs headed Earth's way, but we don't have data from stereo A, so it's very hard to tell if these CMEs are on the opposite side of the sun or the earthly side. So there may be some minor CME impacts coming in the next 3 days or so, but it's all pretty minor. No major eruptions happening there. That was yesterday's imagery. This is today's imagery from the George Mason University. Let's see if any more frames came through. Nope, still 11 frames. And let's move on to the view from the Soho-Lascaux C3. You can see Venus moving into frame there. We also brought up the solar coronal magnetic field, potential field surface source imagery, just for a bonus, just because it's just awesome. And yeah, if any of those CMEs are headed our way, they're pretty diffuse, they're pretty minor. Here's the last 24 hours in Soho-Lascaux C2, Soho-Lascaux C3, and SDO 304 angstroms. Oh my God, it's Nibiru, folks. It's Nibiru. Oh, noes. And by the way, if you think there's a dark star in our solar system or a dark planet floating around, there isn't. Because if there was, people with backyard telescopes would see these objects because of a thing known as occultation. In other words, these objects would get in the way of things that they were looking at, and then they would discover them. So some CMEs happening there, and let's move on to look at filaments. So we've got some serious filaments here. Yeah, Northern Hemisphere rife with filaments. This is the Lermonth, Australia ground-based solar telescope. Huge filament just about to set here on the southwestern limb. And let's continue on. We don't want the video to be too long. We've got weather forecasts and things to come, so let's get on with it. Here is the GOES 16 SUVI for the past about 2.5 hours. Some prominences up here in the northeast, some prominences in the southeast, some prominences in the southwest. So we do have a significant likelihood of coronal mass ejections at the moment. Let's look at yesterday and today's data in multiple wavelengths. So there's SDO 211, 304, and 171 angstroms. Let's zoom in since we show the most detailed imagery of the sun anywhere and the most comprehensive space weather in the world. because it's time for our bonus features. So here is our bonus features of space weather. We've got satellite charging hazards here over Mexico. Moving into the Central Pacific Ocean, those are significant surface charging hazards. They could cause some minor communications breakdowns, a little bit of satellite drag, and so on. Here's the electron flux over the past 3 days, as measured from the geosynchronous near equatorial orbits of the GO 16 and GO 17 at the F layer of the ionosphere. Here is the NOAA forecast. And you can see NOAA actually agreeing with me a little bit there, expecting a little downtick as there is a coronal hole high-speed stream expected. We're still expecting that, folks. It's just showing up a little later than expected. So we can expect a minor downtick there in the electron flux. Here's the one-year chart of the electron flux. To put it in context, that's a greater than 2 mega electron volt electron fluence from Solon.info. And let's move to the ionosphere. So the F layer of the ionosphere is located about 300 kilometers of altitude. If you want to pause the video on this frame because you want to study the penetration of electromagnetic radiation, the temperature of the thermosphere, or the molecular concentrations of that area, feel free to pause the video now. So here's the vibrational frequency at one slice of the ionosphere, the F layer. We are seeing continued high-frequency anomalies here. We've seen them for a couple of weeks. We've covered them every day on the channel. We don't want to spend too much time on that. We'll show the anomalogram, as you may not have any idea what this means. So here's the anomalogram showing anomaly in megahertz from the 30-day median. And we're kind of at the peak of the Russell-Mcferrin effect, which is the acceleration of relativistic electrons in the outer Van Allen belt, which is the reason why September and March are the two most geomagnetically active months of the year. There's the latest image, 10:15 Universal Time, ionogram and anomalygram. Continuing on to show the total electron contents, we're going to show the free electrons over North America. And we're going to show the free electrons over the world. So there's the total electron content over the U.S. and part of the Atlantic and Pacific. There's the standard deviation. Things are still fairly orderly at the moment. Nothing too extraordinary happening. And here's the anomaly from the 10-day average. Some minor anomalies happening there in places like the Caribbean and around the west coast of the U.S. Here's the global view of total electron content. It's showing all of the free electrons from about 12,500 miles of altitude where your GPS satellite's located down to your handset. CTIPE stands for coupled thermosphere, ionosphere, plasmasphere electrodynamics. Those are the most likely places for GPS errors where you see those red blobs. Let's continue on. We've got some weather forecasts to create. We've seen some cold water move in, so that's always a benefit if you want to see a hurricane weaken. I know some channels are saying perish the thought that a hurricane would weaken, but it's distinctly possible. I hate to rain on your parade, but so here's this new sunspot. It is beta gamma class. It has a leading North Pole umbra, and it has trailing South Pole umbrae. So that's what makes it beta gamma class. If it only had one polarity, it would be alpha class. Next, we'll look at this group, since it's quite spectacular. Whoops. What happened? There we go. Let's try that again. So there are the fields. Quite magnetically complex. I still think this back here is going to get named as another group, so we may have sunspot 3110 and 3111. But again, not getting hung up on the names. Here's this new sunspot. It's magnetically complex as well. It's also beta gamma class. In fact, it's beta gamma delta class. So don't be surprised to see some flaring from that. Nope, it's not going to kill you, and it's not going to end civilization. Continuing on, here's our 24 hours of SDO 171 angstroms. And it's time to move to meteorology. So let's blast through the meteorology segment here. And thanks for leaving a comment, Acrylic D. Before we do the meteorology, you're all invited to follow us on Twitter, twitter.com/smashamash. If you don't have a Twitter account, create one. And hold big tech responsible directly for the pathetic censorship that they've brought upon themselves. Look at their stock charts. We've been displaying them and laughing. Thanks to our Twitch followers. Twitch.tv/smashamash is where we stream live most of the time. We did stream live last night on YouTube. Thanks to all of our YouTube subscribers who put up with the pathetic censorship on the YouTube platform. Congratulations on realizing the channel exists. A whopping 43 views on last night's live stream, and we tend to live stream during equinoxes, during solstices, and once again, thanks to our YouTube subscribers. Press like and subscribe if you enjoy the content. Press the share button, leave us a comment, etc. If you're not familiar with smashamash.com/smashteam, it's our subscription services site. So send us a few bucks per month if you'd like to support the content at smashamash.com/smashteam. There's a gold membership, there's a silver membership, and there's even a bronze membership if you are unable or unwilling to open your cobweb-encrusted wallet and send us a few dollars per month to continue to create this content, make it free for all to view, and publicly visible. Thanks once again to the Gold and Silver Smash team for being producers of the content. You can find links to all of that on the homepage at smashamash.com, and welcome to the Neo-Renaissance. In science, we enter a rabbit hole and we ask questions. Sometimes we don't get answers to the questions, and we instead get more questions. And sometimes we even get answers to questions not asked, which is what has happened to our channel. Wasn't really expecting to explain the solar sunspot cycles, but I think I have. Another thing you can do from our homepage is click on this SureMed link. If you'd like to take your own health into your own hands, if you've got some gaps, or if you'd like all kinds of different discounts, click on the SureMed link and sign up via my link. The base membership includes all sorts of discounts, like discounts on prescription drugs, discounts on things like vitamins, discounts on labs, MRI, CT scans, hearing aids, durable medical equipment, vision, dental. Also, virtual veterinarians and doctors by phone are fringe benefits of being a member of SureMed. It is not insurance. It's a membership in the nonprofit organization known as the American Better Health Organization. So check it out. Sign up. It's certainly worth the $20 a month for the base membership. There's also group insurance that you can only get there. Check out our merch shop also. Links below the video to that and on the homepage. To the merch shop, it is in order of best selling. It does contain words that shall not be said on this video. Today's featured product is one that I'm wearing myself, and it is MANSA, which stands for Make Earth Not Suck Again. So we're doing our part here on the channel to make Earth not suck again. Today's hairdo, by the way, is brought to you by the American red-breasted robin. MANSA, Make America Not Suck Again. It's part of the process of making Earth not suck again. As America leads the way, it's still the best place to invest. Civilization's not collapsing, sorry. Sorry if you wish it were, but it's not, because most people don't want it to. Our finest days lie ahead. So do your part in making America not suck again in order to make Earth not suck again, because this is an opportunity to display leadership. If you'd like to purchase a bunker and go hide in it and prep and so on, all that stuff is good, because if something bad does happen, it's always nice to be prepped. However, you may be wasting a lot of time, energy, and resources preparing for things that might not exist. In any case, I would reiterate that our finest days lie ahead, so do your part. It's up to you to make America not suck again, which is not a political slogan. I'm completely apolitical, never been involved with a political party, probably never will. Check out the merch. It's totally sweet. Again, it's in order of best selling. And let's move on. So now we're looking at sea surface temperature anomalies. And we do have some anomalously cold water here, right in the path of that hurricane. So that's a good thing. That's going to weaken the system a little bit there. as convection will be slowed. But then there's also some anomalously warm water there. The good news is that if you look at the raw sea surface temperatures, there is a variation there in the water temperature. So there may be some weakening of that. And we're going to bring up some forecast models. I just wanted to bring that to your attention. And let's take a look at the winds. So there are the surface winds of the eastern world. Here are the jet streams of the east. Here are the jet streams of the west. We got an anticyclone here over Louisiana, Texas area. That's a high pressure zone, an upper level high. Here are the surface winds. And quite high, over 100 mile per hour winds there from that hurricane at the moment. Surface winds of the central world and the jet streams blowing backward over the northern Indian Ocean, parts of the Atlantic, and Central Africa. So here's your weather.gov map, and we see all kinds of warnings here associated with high surf. Also some freeze warnings there in places like northern Wisconsin, northern Michigan, some frost advisories. If your county's lit, head to weather.gov and click your county. And let's break out some forecasts. So first thing we're going to look at is temperature anomaly. Since we've got some extremely cold temperatures coming to some portions of the country, let's do the 72-hour GFS temperature anomaly forecast. So there's that. Some hot weather there in the south central portion of the country and the west. Keep in mind, it's in degrees Celsius. Again, that's your 72-hour GFS temperature anomaly forecast. And we're also going to show some storm track. So let's move our region here. We're going to move to the North Atlantic. And we'll use the pressure and wind for the GFS model also. So we're going to do the same time frame here. 72-hour GFS forecast for wind and pressure. And there's your storm track. There is going to be some wind shear coming down, so that's going to affect things. Also, that cold water, it's going to weaken a little bit, but it's certainly going to bring lots of rain and heavy winds. It's going to crash right into Nova Scotia, especially the eastern portion of Nova Scotia. And then it's going to loiter a little bit, so it's going to bring massive amounts of rain. In fact, let's do the total accumulated precipitation forecast just to see what the rain totals are expected to be here over that same period. So here's your 72-hour GFS total accumulated precipitation forecast in inches. Some very heavy rains there over most of Nova Scotia. Shout out to Ricky, Julian, and Bubbles. Make sure you have your kayaks, your hard hats, your slicker suits, etc. Maybe even some chest waders, as there's some spots there expecting to see over 6 inches of rain. And let's move on. So here's the current state of affairs. Spectacular imagery there from Windy.com's satellite imagery as the sun rises over those high cloud tops. It's a cloudy day in Bermuda at the moment. Here's your lightning mapper. Let's move to a real-time lightning map as the video's getting kind of long here. Here's your real-time lightning map. Do we have any terrestrial strikes in the U.S.? And we just might. Some activity there in South Dakota. Some thunder rolling in there near the Sioux tribe. If you've never seen it before, check out lightningmaps.org next time you hear thunder. It could save your bacon. So we're going to close out with some Doppler radar imagery, shortwave radiation map, and the water vapor map. Once I refresh it. Facts. They're refreshing, aren't they? So here is your U.S. Doppler Radar Map. It's ground-based radar systems measuring vertical motion of water droplets. Here's what's going on over the lower 48. Here's a great imagery from the 3.9 nanometer radiation satellite showing clouds and fog when it's too dark to use the visible satellite. And last but not least, water vapor. And there's some cold air coming down there to strike that hurricane. Let's actually zoom in on that to close out the video. So that cold air is going to affect things. It's going to create some wind shear there, which doesn't aid in convection. It's also entering some colder water there, so we're going to see the winds diminish a little bit. Maybe the pressure will rise a little bit also, but at the moment, expecting a pretty major impact there for Nova Scotia. You can see that cold air coming down from Canada. Facts. We like them here at the Smash News Network, Least Busted Name of News. Thanks for tuning in. I've been your host, Dan, a.k.a. Smash-a-Mash. Once again, congratulations on realizing the channel exists, and may that solar wind be at your back.